Alright guys, here's a problem to look at, so let's read through it. A reflecting surface of a television antenna was formed by rotating the parabola f of x equals 1/10 x squared about its axis of symmetry. If the antenna has a diameter of 4 feet, about how much higher are the sides than the center? Alright, this might actually seem a little bit intimidating. There's a lot of information here at first glance, but I honestly think if you break it up, you're going to see a lot of this is just fluff. So the main thing is, do you understand the problem? So let's break it up. So a reflecting surface television, and the first thing I want to highlight here is rotating the parabola. So the parabola, that's just the graph. So here's my function, f of x equals 1/10 x squared, and again the parabola, it's just the graph of a quadratic function. So here's my quadratic function. So we're rotating this about its axis of symmetry, and I'll talk to you about axis of symmetry in just a little bit. If the antenna has a diameter, so diameter of 4 feet, about how much higher are the sides than the center? So I'm just going to actually highlight sides than center. All right, that's basically what we're trying to figure out. How much higher are the sides than the center? All right, so the first thing I'm going to do is just create a table. I know I'm going to be playing around with the table here. So I'm going to have x and f of x. And before I move forward, I want to talk about an antenna, an old school television antenna, and you might actually see these around still. So I wouldn't necessarily call it old school, but let's just think about our antenna as having the shape of an upward facing parabola, and I know it's upward facing based off the function. I have a positive coefficient of 1/10. Okay, so I have an upward facing parabola, and then what they're also telling us, and I'll show this later too, is that the diameter of this parabola, that diameter right here, the distance across from side to side, it's 4 feet. So 4 feet. In fact, I'm taking up too much space there, so 4 feet. I'm going to see if I can make it smaller. Maybe I'll just put it on the outside. So just know that this diameter here is 4 feet in length. And then let's talk about the axis of symmetry. Alright, so this axis of symmetry, it's an imaginary line. It actually splits the parabola in half. So I'm just going to draw some arrows here. This is an imaginary line. It splits the parabola in half, and the point that's on this axis of symmetry right here, that point, it's the vertex. In this case, since I have an upward facing parabola, I know the vertex is the minimum point on this parabola. So that's the point on the axis of symmetry. That's just a key information, or a piece of information we're gonna just keep in mind. So I'm just gonna write the vertex there. Vertex, that's my vertex. And now I'm gonna actually use this function to figure out some values here. All right, so let's play with a few here. So when x is -4, -3, -2, -1, 0, 1, 2, 3, and 4, and let's fix that 4. And I'm going to actually bring that line down just a bit more. All right, and I'm going to just bring that down some more. There we go. All right, so f of -4 is equal to, well, you could use 0.1, and if you want, and use a calculator. I'm going to write that as 1/10 as a fraction. So 1/10, 0.1 is the same as 1/10. X, in this case, -4, 1/10 times -4 squared. So I have 1/10 times 16, and 16 over 1, that's what I'm going to write that as a fraction. So -4 squared is 16, and 16 as a fraction is 16 over 1. Now all I have to do here is multiply the fractions, and I have 16/10. So f of -4 is equal to 1.6. So 1.6 here. All right, so f of -3, it's equal to 1/10 fix that fraction bar there, times -3 squared. So we have 1/10 times 9. -3 squared is 9, so I'm going to write that as a fraction. It's 9/1. And f of -3 is equal to, well, 9/10, or simply 0.9. Border that off. Alright, f of -2 is equal to 1/10 times -2 squared. So we have, in fact, I wrote, I'm going to fix that. I wrote 1/2 here. So I'm going to get rid of that 2 and turn it into a 10. Alright, so 1/10. Right, so now I have 1/10 times -2 squared. -2 times itself is 4 over, as a fraction, 4 over 1. Alright. So f of -2 is equal to, well, 4 over 10. So 4/10. 4/10, and 4/10 is the same as 0.9. So, not 0.9, 0.4. 0.4, which is 4/10. And let's box that up. Alright, f of -1 is equal to 1/10, fix that, parentheses, times -1 squared. So we have 1/10 times, well, -1 squared is 1. 1 as a fraction is 1 over 1, which simply just gives me 1/10 still in the long run. So f of -1 is equal to 1/10, or simply 0.1. Border that up. Alright, so f of 0 is equal to 1/10 times, or in fact I'm just going to put that in parentheses, times 0 to the second power. And 0 to the second power, 0 times itself is 0, so I'm left with nothing times 1/10, or 1/10 times nothing, which will give me 0 in the long run. So f of 0 is equivalent to 0. When x is 0, f of 0 is 0. Border that off. Alright, f of 1 is equal to 1/10 times 1 squared. 1 squared will give me 1. Change colors there. So I have 1/10 times 1, or 1 whole. And 1/10 times 1 is the same as 1/10. So f of x is simply 1/10. F of x is 1/10, and 1/10 we've already determined is 0.1. It's the same thing as 0.1. So 0.1. Border that off. Alright, f of 2 is equal to 1/10 times 2 squared. So I have 1/10 times 2 squared is 4. 4 written as a fraction is 4 over 1. Alright, so now 1 times 4 is 4. 10 times 1 is 1. So I have f of x, or not x, f of 2 is equal to 4/10. And 4/10 is simply 0.4. And I think you're starting to see that mirror effect now. So 0.1, 0.1, 0.4, 0.4. I'm guessing that for positive 3, you're going to find that f of positive 3 is going to equal 0.9. Let's just check it out still. And I'm going to get rid of a lot of this information. I'm going to see if I can just move all this information over before I delete it, just so we can look at the last two problems here. Alright, so f of 3, it's equal to 1/10 times 3 squared. So I have 1/10 times 9. 9 as a fraction is 9 over 1. Alright, so 9 times 1 is 9. 10 times 1 is 10. So f of 3, it's equal to 9/10. So yeah, we're seeing that mirror effect still. So we have 9/10. Border that off. And f of 4, f of positive 4, it's equal to 1/10 times, in fact I'm going to get rid of that decimal, or not the decimal, multiplication symbol, times 4 squared. So now we have 1/10 times, well, 4 squared is 16 over 1. So now I have 16 times 1 over 10 times 1. So f of 4 is equal to 16 tenths, or 1.6. And I'm going to get rid of all that extra information that's not needed now. All right. And just fix that error real quick. Alright, and now I'm going to draw that coordinate plane, but I'm not going to plot all the points. You'll see why in just a minute here. And let's do that. Get that last arrow on, and I'm going to make this first tick mark up high, just so we have a lot of space. And then about halfway in between, I'm going to put a minor tick mark. And I'm going to actually say that this represents 1 unit of space right here, just moving along the y-axis. And then I'm going to make 1, 2, 3 tick marks that are each 1 unit in length. So 1, 2, 3, and in the opposite direction, -1, -2, -3. So -1, -2, -3. So moving along the x-axis, each tick mark, the change here represents 1 unit of space, but moving along the y-axis, this tick mark represents half a unit of space, and this is 1 unit of space. And this is just to get a better view of the graph that we're going to plot here, that parabola. And again, I'm not going to plot all the points. I'm going to start at actually -2 here. Actually, let's do -3. So -3 and 0.9. So -3.9 should hopefully be up higher. So right about here. All right, -2.4. So -2, and right below that halfway mark, 0.4. At -1, we're at 1/10. So -1, we're at 1/10. It's going to be much lower. At 0, 0, that's the next point. 1 and 1/10. When x is 2, y is 4/10, so right up about here. And then finally, when x is 3, y is 9/10 again, so 9/10. Okay, so now I'm going to try to draw a line as best as possible through these points. And it looks like it's messing up right along the end there, so I'm going to try one more time. So going through the points. All right, and then we're having that upward curve. And this is an antenna. It's not going to go on forever, so rather than drawing arrows, maybe I'll just draw some little antenna balls for this antenna. All right, and let's just fix these balls, just fill these balls in just a little bit here. I'm just filling them in. All right, and now let's actually go ahead and take a look at what the parabola is telling us. In fact, you know what I'm thinking here? I probably need to erase these balls and make them a different color, just so we know that they're not actual points on the parabola. Maybe they're just, I guess they could be points on the parabola, but maybe they're the last points on the parabola. So here we go. here's our antenna. And what's this problem really getting at here? The last thing I want to do is erase that value. I don't think we need it anymore. Well, the problem's asking what's the height of the sides, or what's the height of the antenna when the diameter is 4 feet in length. Now be careful, that's not saying when x is at 4 or -4 units. This is not important. I'm not interested in this value for x. I'm actually interested in the diameter of the antenna when it's at 4 feet in length, and it's actually going to be right here when x is at -2, when x is at -2, and at positive 2. So it looks like I made a little error on that point, so maybe I can go and fix that real quick. That point should be just a little bit higher so that it matches the other on the other side, but this is 4 feet in length here, and I can verify that. So what I'm seeing here for x, the absolute value for x for this point, it's 2 units away from 0. So this is 2 units, or I guess 2 feet in this case, away from 0. And on the other side, x here, it's the absolute value. It's also 2 units away from 0. So another 2 feet and 2 feet and 2 feet. That's going to give me 4 feet. So what I'm really asking here is what's the height when x is at 2 feet? So what's the height of the antenna here? Well, the height of the antenna here is at 4/10 of a foot. So what I'd write here is that the sides of the antenna, the sides are 4/10. I'm just going to write 0.4. You could write 4/10. 4/10 of a foot higher than the center. In fact, that should be than the center when the diameter is 4 feet in length. When the diameter fix that T real quick. Let's try that again. There we go. Diameter is 4 feet in length. And then you can box this up. Cool, I'll see you in another video.